Problem similar to an SMO junior problem. Now let's note that the solution x is not equal to 0. In other words, 0 is not a solution to this thing, which is important as far as the way this develops. So x cannot be equal to 0, and that's clear by inspection right here. Okay, now we're supposed to evaluate x to the 8th plus 1 over x to the 8th. And one way would be to directly solve this. You get a surd, and you could do it directly, but that's a little bit of a pain. So what we can do, since x is not equal to 0, we can divide the given. We can divide this given by x, and that results in this. Now this form right here, the sum of a number and its reciprocal, actually motivates the following algebra right here. Now I'm sure you guys see this, but if you expand this piece out right here, you get what? A squared plus 2 times a times 1 over a, right? And so you can see exactly why the result to the right of the equality holds. A over 1 over a is certainly cancels, right? Just for a value of 1. And then right here we have plus, when you square this last part, this is just, you know, the binomial. So 1 over a quantity squared. We'll just write it as 1 over a squared, right? Okay. So again, this a cancels this a, yielding 1, and that's where this 2 comes from. Now, it makes sense to be interested in this particular algebraic nicety, I guess, since we have this as more or less equivalent. You know, it is equivalent to this original equation. They have the same solution sets. So let's take a look at how that gets used. And really, you just use it repeatedly, and you can see what's going on here. I won't bore you too much, but it's convenient to write this like this, subtract the 2 from this side, right? And then you can see that the given x plus 1 over x quantity squared would be 81 right here. Okay, so this is 81, right? Now notice, if 9 is the last digit of any natural number, and then you square that natural number and subtract 2, you're going to get 9 as the last digit of that result. And notice I did the work for you right here, but it's just true. It's just a truth. If you square any natural number that ends in 9 and then subtract 2, you're gonna be ending with 9 in the result. Okay, the resulting integer will have to end in 9, and it's very straightforward to see. 9 squared is always going to leave a 1 at the end of the result. When you subtract 2 from that, you'll end up with a decremented value that has 9 as the last digit, right? And so right here, without actually doing the work, we see the pattern emerges right here, that this guy right here, I'll circle this object, has a last digit of 9. Has last digit of 9. Okay, for this particular problem, I guess you could, whatever the setup was for another problem, you'd notice something like this also. But anyway, that was what the question was. It says, what is the last digit of x to the 8th plus 1 over 8? And that would be 9. Okay. All right. So you can also circle that if you want to, if you're looking for a place for a circled answer. And also notice, possible but impractical would be to solve this quadratic. You would have something like, I think, root 77 somewhere. 9 plus or minus root 77 over 2, I believe, is what you get. And that would be a little bit of a hassle, you know, to raise all that to the 8th power and then raise the reciprocal to the 8th power and add them together and then see what the last digit was. That would be rather painful. Maybe there'd be some niceties of that too. But anyway, this piece of algebra right here is what turned the trick for us. And anyway, I think we have completed the problem. Hope you enjoyed.